Welcome to this explainer. Building a house is probably the absolute biggest investment most of us are ever going to make in our entire lifetimes. But think about it. When we walk through a home, what do we actually look at? The paint colors, right? Maybe the kitchen countertops, the lighting fixtures, but we have literally no idea what is actually sitting right behind that drywall. Well, today we are going completely behind the scenes to uncover the foundational blueprint of residential building.
Okay, let's dive right into this. Do you actually know what is holding up your roof right now? I mean, it sounds like a super simple question, but the answer dictates the entire skeleton of your home. And understanding this structural backbone, it isn't just for architects or contractors. It is absolutely crucial for your wallet, your home's overall energy efficiency, and, let's be real, your family's safety.
So here is our blueprint for today. First, we'll look at the 5 core construction methods. 2, luxury and modern innovations. 3, insurance and climate considerations. And finally, 4, choosing your perfect build.
Section 1, 5 core construction methods and the building blocks of your home.
The whole residential construction industry basically relies on 5 major methods. We've got wood frame, steel frame, concrete, modular, and ICFs. And the cool thing is, every single one of these was developed to solve a very specific building problem. But of course, they all carry their own unique drawbacks too. So let's break down exactly how these methods actually work, starting with the 2 most common framing types. First up, wood frame construction. This is your classic method. It relies on widely available timber to create a flexible, super cost-effective skeleton that naturally provides pretty good insulation. Because it's wood, it is incredibly easy to modify. Like if you want to build an addition later on, it's no sweat. Though you might need some extra fireproofing depending on where you live. Now contrast that with steel frame construction. If wood is the flexible classic, steel is the impenetrable fortress. It is designed to completely resist pests and fire, which makes it absolutely ideal for areas prone to extreme weather or earthquakes. But that hardcore structural integrity comes with a higher price tag. Plus, builders have to really carefully manage something called thermal bridging, which is where the metal can rapidly conduct outside heat or cold straight into your living room. All right, next up is concrete. Now, when we talk about how concrete works, specifically reinforced concrete, we instantly think of pure, unyielding strength and longevity, right? It is the go-to method for multi-story builds because the maintenance is just so incredibly low, but its real hidden superpower is thermal mass. The sheer density of the concrete actually absorbs and stores heat energy. It acts like a massive buffer that heavily contributes to a home's overall energy efficiency. The catch here, you're definitely paying a steep initial cost up front, and you absolutely need highly skilled labor to pour and set it correctly. Moving completely away from traditional on-site building, we have modular construction. Now, this method fundamentally changes how a house is built by changing where it is built. It all starts with factory assembly. They build these massive sections of the house in a highly controlled environment. Next comes the transportation logistics, and finally, the on-site setup, where the pieces are literally craned into place and stitched together. By building off-site, you are saving massive amounts of time and money, all while keeping that perfect factory-level precision. The trade-off, though, you're going to have some limits on custom designs, and yeah, you have to meticulously figure out how to safely drive an entire living room down the highway at 60 miles per hour. Now, if you want to combine structural strength with absolute peak energy efficiency, we turn to insulated concrete forms or ICFs. So how do ICFs work? Well, instead of traditional wood or steel framing, builders use interlocking foam blocks. Think of them almost like giant structural Lego pieces. Once these foam blocks are stacked up to form the walls, the hollow centers get completely filled with poured concrete. What you're left with is a highly insulated, incredibly energy-efficient building envelope. It's spreading like wildfire in popularity because of its sustainability and that amazing thermal performance. But since you're using specialized foam forms and poured concrete, you're looking at higher material costs, and you definitely need a crew with specialized installation knowledge. Section 2, luxury and modern innovations, pushing the boundaries of building. So what happens when you step into the world of luxury homes? Well, builders basically elevate those foundational methods we just looked at. They'll integrate custom masonry right into the structure, handcrafted stone and brickwork that adds not just timeless elegance, but amazing durability. During the actual construction phase, they are hardwiring smart home integration. They bake automated lighting, advanced climate control, and seamless security directly into the bones of the house. And more, luxury is becoming synonymous with green building. We're talking reclaimed materials, huge solar arrays, and rainwater harvesting systems that make these massive footprint homes remarkably eco-friendly.
But innovation isn't just about the fancy finishes, you know? It is about the actual raw materials we use. Take cross-laminated timber, or CLT for short. This is a brilliant, highly sustainable alternative to standard wood framing. It offers so much stability that it can actually be used to build multi-story buildings. Beyond CLT, modern methods are drastically changing construction speed. We're actually seeing the rise of 3D printing now, which can create really complex structures with wild precision while heavily reducing both waste and labor costs. We're also seeing prefabricated panels that get built off-site and arrive with all the insulation and wiring already integrated inside them. It completely streamlines the whole on-site building process. Section 3. Insurance and Climate Considerations. Grounding Theory in Reality.
It's one thing to talk about all this building theory, right? But the choices you make on these construction methods will directly impact your wallet long after the builders pack up and leave. Now, what's really interesting here is how insurance companies evaluate your home skeleton. They're looking purely at durability, fire resistance, and overall risk. Brick and concrete homes, those are typically evaluated as lower risk. Because they're so highly fire resistant and durable, choosing these methods can actually score you lower monthly insurance premiums. Wood frame homes, on the other hand, while they are incredibly common and super cost-effective to build, carry a higher risk profile. If you're building a wood frame house in an area that's prone to wildfires or termites, the insurance company is taking on more risk, and for sure, you are going to be paying higher premiums.
And that brings us to a really vital concept. Your local climate essentially dictates your construction choices. To really put this into perspective, let's look at a Boston case study. Look, building a home in Boston is just not the same as building a home in Phoenix or Miami. The unique, highly variable climate, the historical architecture, and the very specific soil conditions up in New England absolutely demand specialized architectural adaptations from the literal day you break ground. So how exactly does a builder adapt to a demanding climate like Boston's? Well, they rely pretty heavily on brick and stone construction. Not only does this honor Boston's deep architectural heritage, but remember that thermal mass we talked about earlier? It beautifully insulates against those freezing, bitter northeast winters. Also, because the climate swings so wildly, standard insulation often just doesn't cut it. Builders will upgrade to advanced techniques like spray foam to tightly seal up the building envelope. But honestly, perhaps the most crucial thing they have to consider is the ground itself. Boston soil is prone to something called frost heaves. That's where freezing moisture expands and literally pushes the ground upward. To survive that, builders absolutely must use resilient foundations. They opt for deep foundations or these specially engineered frost-protected shallow foundations so the house doesn't just crack under the intense pressure of winter. Section 4. Choosing your perfect build, balancing cost, quality, and environment. Ultimately, choosing the right construction method is really about matching your highly specific needs to the right structural blueprint. If you are prioritizing budget and want maximum flexibility, traditional wood framing might just be your answer. If you live down in hurricane territory, steel framing or concrete are likely your best bets. And hey, if you want maximum energy efficiency and to be as eco-friendly as possible, you're definitely looking at ICFs or modern CLT. The ultimate goal here is navigating this giant puzzle of cost, quality, and environmental impact so that the home you build today will effortlessly stand the test of time tomorrow. So I want to leave you with this final, thought-provoking question to reflect on. If you were breaking ground tomorrow to build your absolute dream home, armed with the knowledge of how these structures work and what actually happens behind the drywall, which of the 5 main methods would you trust to protect your family and your investment? Thank you so much for joining me for this explainer, and remember to always keep questioning what's beneath the surface.